This video describes an experiment that will enable you to measure the circumference of the Earth. And for this, you'll need yourself and a friend. Now, your friend needs to live due south of you and a few hundred kilometers away. You'll see why later on. And at each location, you will both need the following apparatus. First of all, a stick. Now, this stick is going to be stuck vertically in the ground with a metre protruding, so you'll need a stick that's perhaps 1.2 meters long. You'll also need a ruler or a measuring tape, and you'll need a mobile phone because this experiment must be done at the same time by both of you. I'm assuming also that you've used an atlas to find out the distance between yourself and your friend. So, what do you do? Well, as I've said, you put the stick in the ground vertically with a metre protruding. And of course, you need something else, which I have no control over, and neither do you. You need a nice sunny day, because your stick will then cast a shadow on the ground, and you need to measure the length of this shadow. So you get on the phone to your friend and say, right, now measure the length of your shadow. And you've both got a metre high stick, and you both measure the length of the shadow of the stick. Those distances D1 and D2 are absolutely crucial. So you can use those distances and the length of the stick above the ground to calculate A1 and A2, which are the altitude, elevation of the sun at that particular time at both the locations. Now we've sort of stepped back now to take a larger view. So you can now see the two sticks marked there and there, and because they're verticals, if you were to produce the line onwards from the vertical of each stick, they will meet at the center of the Earth. And you can see the two shadows. This is a much exaggerated version because I've got to show big enough angles to mark. So you've measured angle A1, remember that was at the location 1, and A2, the angle at location 2. And they were the angle, remember, that the sun's rays formed with the surface of the Earth. And therefore, if you look at the geometry of the thing, the difference between A1 and A2 will be the angle where the two vertical lines meet at the center of the Earth. And therefore, we know that angle. But what else do we know? Well, you've already looked up this distance between location 1 and location 2. So we know the angle at the center of the Earth. We know the length of the arc there, and therefore we know that it's a certain fraction of the complete circumference of the planet. And we'll now look at some actual results. This is the results of a set of measurements that I took earlier on. And for this, location 2 is 1250 kilometers south of location 1. Now, both of them were in the northern hemisphere. Now for the shadow length. The shadow lengths of these metre long sticks that were placed vertically in the ground at location 2 was 60 centimetres, and in location 1 was 90 centimetres. And remember, they were both taken at the same time. And you can see that the shadow length for location 1, that's the one that's further north, was bigger than the shadow length at location 2. Well, that makes sense because the further north you go, if you're both in the northern hemisphere, the altitude of the sun at the same time is going to be less, so a longer shadow. And here are the angles. For location 2, the sun's rays made an angle with the Earth's surface of 59 degrees, and at the location 1, they made an angle of 48 degrees with the Earth's surface. So this 11-degree difference is equivalent to a 1250 kilometre separation. Well, what about a 360-degree difference? Now that would be going round the whole circumference of the planet. So that distance would be 360 divided by 11 multiplied by the actual distance between my two locations. And therefore the circumference of the Earth is 360 over 11 times 1250, which is 40,909 kilometres. Well, the accepted value is something over 40,000, but remember that this is only quite a simple experiment, and also the Earth itself is not exactly spherical.